Factor Fest, page 6. This is where it starts getting crazy. So with this work, you really got to be detailed. You have to notice the attention to the details, and you have to write things in an organized fashion. So we see this, and we see that they have a common binomial. And that's good because we can pull that out and we can get p to the fourth minus q to the fourth. Now, we would want to rewrite this in standard form. We can write this as, q, as the difference of two squares. And if we factor out the negative, we notice that we get the difference of squares in that term. And so this we're going to tackle as the difference of two squares. So that's my a minus my b, and then my a plus my b. And that's good. And we can factor this as the difference of squares. So they're going to produce conjugates. And we also notice that this is the difference of squares. So we're going to do the conjugates again. We're going to take the square root of each of those and do plus and minus the values. P squared plus q squared cannot be factored, so we get that long. And that didn't take long, and it's through recognition, it's through lots of practice that you become able to factor these with that efficiency, with that speed, recognizing, and you got to do a whole lot of them. And that's good and it's important. So 12, 16, 35 has no factor. It is in standard form. So we're going to do a times c, where a is 12, c is negative 35. That's a big number, negative 420. So factors of 420 are going to be 1 and 420, 2 and 2100, or 210, 3 and 140, 4 and 105, 5, oh, yes, 5 goes into that. I don't know why I didn't do 5. That's interesting. 5 and 84, 6 and 70, 7 and 60, 10 and 42, 12 and 35, and 14 and 30. I don't have to keep going because I notice that my signs are different and the bigger is positive. Signs are different. One's negative, one's positive. So I know that those aren't going to work because my middle is 16. So I got to find a pairing that when combined equals 16, and that would be there. I can stop. So I'm going to take negative 14 and 30. So 12m squared, negative 14mn. Remember, this term is going to be this term. And then plus 30mn minus 35n squared. We're going to factor by grouping. And we're going to take out a 2m. We factor out a 2m, we get 6m minus 7n. We're going to take out a 5n, and we get 6m minus 7n. We know we did that correctly because they're the same inside the parentheses, and we're left with 2m plus 5n. So there you go, number 76. All right, we have two terms. It can be either the difference of cubes, or the difference of squares, whichever one we want to look at. I'm going to do cubes. I'm going to see, because 125 I know is a 5 cubed, and then we can write x to the third, or excuse me, x squared to the third minus 216, which is 6 cubed. So if I write 5x squared quantity cubed minus 6 cubed, I get my difference of cubes. And that's going to be a minus b a squared plus ab plus b squared. Hopefully you're getting better at this and you're going to remember those two. So we get 5x squared plus, minus 6, and we get 25x to the fourth plus 30x squared, that's a times b, and then plus 36. So I'm pretty sure that was the correct answer. 5x squared minus 6, 25x to the fourth plus 30x squared plus 36. Yes. So I'm going to check and see. I see three terms. I see a perfect square. That's 2z. That's 7 multiplied and doubled times 2 gives me 28z. So I know that it's a binomial square. So I'm going to take the square root of my first, which is 2z. Square root of my last is 7. This sign is always going to be inside there. And I get 2z plus 7 quantity squared. Recognition. The expression is equal to, oh yeah, I had no idea about this one. I mean, this is crazy. I'm assuming it's either A or D. I don't know what, maybe I do now. Now that I've done some more practice. No, I don't know. I mean, I see that you can factor out an x. I see that we can simplify that. So you get xy minus 36x, and then you can factor out an x, you get y minus 36. So, you know, that's how I would factor that, is equal to. And I multiplied all these out, and none of them equaled this. The thing is, I think that this one, we have to add a positive and a negative of something, like an x squared or something. I mean, right? Do you do x squared minus x squared and then attach this with two of them, and then maybe do, I don't know. I have no idea. This one was hard. This one definitely got me. Can you do the difference? Can you do maybe factor by grouping? Could you do, well, let's see this. Right. So, and what I tried to do, I tried to reverse engineer it. That's why I pushed these out and I simplified them to see. You know, that's 2y squared minus y minus 36. Okay, so we're kind of close. Can we get that from this? And I don't know, can I take this and do something to get two factor pairs? This one had me stumped, so I don't have an answer for 79. I should spend a little bit more time now that my brain is fresh, but yeah, I'm not gonna do that. This was another crazy one. What did I do? I think I did this. I'm looking at my notes and seeing what. So I think the answer is D. And how I came out with that, I have no idea. But I think I substituted. So you have 25x squared. Let's do y to the negative 3 halves plus 6x y to the negative 1 half. And there was some, I was looking online for stuff that kind of made sense. Yeah, you know, I don't know this one. 80 was hard too. So this, like I told you, this page started to get really challenging. We might come back to 80, but those two had me. 81, we're back to okay. I know how to do this. This is in my realm of work that I'm comfortable with. When we convert division to multiplication, we have to flip the right term. We're also going to minus 2a minus 2b, and now we're going to factor some stuff. So I'm going to keep this as that and this as this times 12 over, I'm going to factor out a -2 and we get a plus b. So now what can we cancel? So we can cancel the a plus b and a plus b because it's being multiplied. We can cancel the 6 and the 12, becomes 2. We can factor the -2 and the 4, that's -1, and this is 2. And that's what we're left with. So we're left with 4 over -a squared b cubed. That negative can go in either place. You can also write it like that if you'd like. Both of these are correct, and I feel real comfortable going back to this. So 7980, kudos to you, my friend. You have bested me. This is the difference of squares times. That's interesting. They use an x. In high school, we kind of move away from using x as a multiplier, showing multiplication, because it looks like a variable. Let's factor that numerator. That's going to be 2b, and we get b minus 5. Factor this. That's a binomial square. I can recognize that. So let's start canceling. We have a b minus 5. We have a b plus 4 is going to cancel with one of these b plus 4s. And that's it. So we're left with 8b over b plus 5 and b plus 4. So that's can't be simplified any further. That's good. Again, we're going to convert that division to multiplication. We get x plus 2 in the numerator. We can factor this. Hopefully, you now see how to factor that. You should eyeball that. You should be able to factor that by eyeball, or mental math, should we say. And so this term's going to go in the denominator. That's the difference of two squares. And we should be able to factor this. Also, that's plus 3 plus 2, and we get really good. That's something in Algebra 2, Honors Algebra 2, you should be able to eyeball factor any quadratic expression with a value of 1, or a coefficient of x squared is 1. You should see what that's going to be. So now let's start canceling. You have x plus 2, we have x plus 3, and that's it. So that's going to simplify to x plus 2 over x minus 2 quantity squared. I think that that's a okay version. I don't think you'd want to simplify the quantity x minus 2 squared. I don't see the benefits of that. We can factor out an x. That gets us x squared minus 6. Oh, not in standard form. All right, so first thing we're going to do, x to the third plus x squared minus 6x over, this is x squared minus 5x minus 6 times x squared minus 2x minus 24 over x to the third plus 2x squared minus 8x. So getting it in proper form is going to help us come out with the right answer. So let's factor out an x. You get x squared plus x minus 6 over, let's break that up. That's going to be x minus 6, x plus 1. That's an eyeball, mental math one. This is going to be x minus 6, x plus 4. We're going to factor on an x. You get x squared plus 2x minus 8. Let's factor this numerator. That's going to be x plus 3, x minus 2 over x minus 6, x plus 1. Let's factor that numerator. Oh, no, that's already factored. X minus 6, x plus 4. And we have x times minus no, plus 4 minus 2. So let's cancel. Well, the x's are going to cancel, numerator, denominator. X minus 6, x plus 4, x minus 2, and we're left with just two terms, two binomials. X plus 3 over x plus 1 should be my answer. And that's it. That is page 6. Another doable. So yeah, 79 and 80 kind of drive me crazy. I'm kind of disappointed in myself on not being able to see what that is. Those are tricky. That negative exponent, yeah, we can talk about it. Let's talk about it a little bit. So when we should know, right, when we have x to the negative 3/2, we can rewrite this as 1 over x to the 3/2. That's one way of looking at it. And then we can rewrite this also as 1 over the square root of x to the 3rd. So writing it in, this is radical form, and this is exponential form. So I don't think it benefits us. Well, right? And then x to the square root of x to the 3rd is equal to x rad x. I don't know if that's going to help us. Does that help us in this problem? I'd probably say no. No, let's see, right? So this is 25x squared over, and that's going to be y rad y plus 6x over y square root of y. Okay, so if we make this 25x squared y rad y, and let's get a common denominator of y rad y, so that would be 6xy. Now those are the same, so that's 25x squared plus 6xy all over y rad y. Does that help me? I don't know. Is that one of the answers? Doesn't look doesn't look like it. All right. Well, then can we complete the square thing by doing that? So now we can just take these terms here, and we can. All right. I see. So if we do negative y squared, if we do plus y squared and minus y squared, does this become a binomial square? No, but that's pretty cool though. And well, so what do we need? We need 5y. So what if I subtracted an xy minus xy? Okay, no, because that really doesn't help me. I don't know. Now I'm just stretching. Sorry. I don't know. I'll end the video. Sorry. Thanks for hanging out for an extra 2 minutes.